when we waxed them. And then you'll go to
I have like at least 3 fishes.
it's only 3 of them. But they're your first percent.
It's pretty interesting.
So do you want to start on like species 3?
Honestly, we'll just like call it crinoid facies. Like let's just call it waxstone facies. And then we'll just like well, we're gonna be going with the same document actually, so we can just call it something. Stick with it.
Yeah.
Structures. They barely have one in there. So Paul.
Okay. I'm gonna go downstairs and grab plates if you want to grab these. I'll be right back.
Okay, back. Where's the other one?
Just one each?
Yeah.
A lot of pizza, not a lot of people.
That's why we come to
Be somewhere here, it's closer to the mic. Can you stay somewhere in this half? Okay.
I'm going to stay here.
Okay.
Okay? Go. Just don't let it get cold.
No, go for it. Yeah, all yours.
Do we have anybody listening? Can you tell?
Not now. I will look at it.
This is a tough decision. I don't have enough plates, but I have tons of napkins. Someone ate the plates with the pizza. I don't know. Because they gave us like 40 plates yesterday, so I'm not sure. This is the other receipt, just in
Okay.
case.
You guys pick first.
I'm not an olive fan, but like apparently it's very good.
We did our best. And this time
Yeah.
it was good enough.
They don't usually forget stuff.
First time ever. Yep.
Everybody's eating now. We'll keep this informal. And if you get hungry in the middle of the session, just go help yourself to some more pizza. My name is Nick Harris. I've been teaching here I'm in my 9th year, I guess, and I direct the Integrated Petroleum Geosciences program. Elena Konstantinovskaya is my colleague. She's the associate director. And what we want to do tonight is tell you something about the program, what we teach in it, what we're preparing you for, the kinds of jobs we're preparing you for, whether you're going to get a job or not, and there's lots of time for you to ask questions. And as I say, it's going to be informal, and if you want to ask a question in the middle, just go ahead. That's fine. We're also connected so that people who are we've advertised this on LinkedIn, and so there are some people who are, we hope, listening to this remotely as well. We're in the 9th year of the IPG program, so we've been at this for a while now. The IPG program started because oil companies in Calgary came to us, to the university, and said that their new hires were not prepared enough to really be productive employees when they first started working. So they'd hire a new grad, and what the companies found was that it was taking 3 years, 4 years before the people, their new hires, really knew enough about the business so that they were contributing effectively to the company. They were still basically learning on the job, and so the companies wanted to know if we could design a program that would basically provide advanced training so that somebody coming out of the program would be prepared to enter as a productive employee basically from the moment they were hired. So the program that we teach is intended to give you the skills that you need so that whether you're working as an exploration geologist or a production geologist, whether you're doing well site work, whether you're working for a consulting company or a service company, that basically you know enough that within months after you start working for a company, you're being as productive as anybody who's been working for a longer period of time. The other piece of this is that oil companies now work in multidisciplinary teams, and this is a big change. I worked for Conoco before it was ConocoPhillips. I worked for Conoco for 15 years. And when I was there, the oil and gas business or the exploration development side of oil and gas was very much a sort of thing where a geologist or a geophysicist would identify a prospect and work up the prospect, and he or she would finish it and say, okay, geologist, you take it. And the geologist would do whatever their thing was, figuring out the porosity and permeability of the reservoir. And then the geologist would hand it to the engineer, and it was kind of handed off, person to person. And in the end, somebody made a decision on the basis of that work. These days, everybody works in multidisciplinary teams. So a team of people will work up a prospect, and it will include the geophysicist and the geologist and the engineer, and they're all supposed to work together towards a common goal. And part of working together towards a common goal is you know enough of each other's language and enough of each other's science so that as a geologist, I'm telling the geophysicist information that I know is critical for the geophysicists to do their work well, and I can also talk to the engineer and tell the engineer enough about what they're doing in a language that the engineer understands, that the engineer can do his or her job well. And so the program that we designed is set up so that you learn something about all the major facets of doing oil and gas exploration. So the way we do that is we have a set of core courses, 5 core courses in the program, academic courses, that everybody takes, and then a set of optional courses that allow you to specialize. So the 5 core courses are basin analysis, tells you how to think sort of synoptically about, sort of a big overview of how sedimentary basins work. Reservoir geology, seismic interpretation, well logging and petrophysics, and what am I leaving out, Elena? I'm leaving out
Seismic, well log analysis.
well log interpretation.
Petroleum production.
Petroleum production, so reservoir engineering, basically a reservoir engineering class. It's taught by our petroleum production class is taught by an engineer who works for Alberta Innovates, but because we're teaching it in Faculty of Science, the engineers didn't want us to call it an engineering class. So the engineers said, call it something else. So we call it petroleum production, but it's basically a first introductory reservoir engineering class. So that set of 5 courses gives you basically that multidisciplinary overview of how we all do our business. These are all graduate level courses. These are 500 level courses. They assume that you have a good, solid foundation in geology or geophysics. We don't stop. We don't go back for to cover basic stuff. This is advanced training. You also take 4 optional courses, and the optional courses are either in EAS, in Earth and Atmospheric Sciences, or they're in geophysics. Occasionally, people have strayed out of Faculty of Science to take courses in engineering. But they allow you to specialize. And so specialty courses might include 500 level courses in sedimentology, clastic sedimentology, or carbonates. They might include advanced, they might include structural geology. Elena teaches an advanced seismic interpretation class. In geophysics, there's seismic data processing, there's wave theory, so there's some fairly advanced stuff there as well. So by the end of the program, you've got all of the disciplines covered to give you breadth, and then you've got 4 courses to allow you to specialize to some degree. We also, the last main primary component of the program is a capstone project. So the 9 academic courses basically take you through the fall and winter semesters. You're doing typically 5 graduate courses one semester for the next. That's a very significant workload. And then starting in May through the middle of August, you do a capstone project, which the idea behind the capstone project is that you've taken all of the skills that you've now learned and you apply them in some practical way to solving an exploration problem. When the program first started, we were doing, every student was doing an individual capstone project. So somebody might work up the reservoir geology of the flare formation in western Alberta, something like this. We've gone now over the last 2 years to doing primarily team exploration projects. So we form multidisciplinary teams. We've been using teams of 4, so one student doing the seismic interpretation, one student doing reservoir geology, one student doing petrophysics, and one doing petroleum charge. And most of the projects have been with very very integrated data sets from offshore UK. So North Sea, major petroleum provinces there, and basically you're an exploration company, or you're the exploration department in an oil and gas company, and you're charged with identifying prospects and justifying drilling them. We've also had a couple of times we've had students doing team projects looking at unconventional reservoirs, and in Alberta. It's been interesting. We rely on companies to provide us with good data sets to do that. And we may get one again this year. We'll see. There's one of the lower Cretaceous sandstones. I think it's Cardium, if I remember correctly. There's a company in Calgary that is trying to work up low permeability reservoirs on the flanks of major fields, and they'd be interested in having a team of students basically work on that, trying to develop new models for exploring these areas, basically moving out from conventional plays into unconventional plays. So that basically is the year. You start in September, you finish in August, and if you've survived all of that, you've got a master's degree. It's a significant workload on the students in the program. Have to manage in addition to, say, the normal, the sort of normal small project labs that you typically do. Most of the courses also involve major projects. So for the example, I teach the reservoir geology class, which is almost wrapped up now. And we do 2 major projects in that. The students right now are finishing up an exercise that looks at, uses some core from our core repository on campus to, they develop a sedimentological model for the core that we give them. It's a heavy oil play from the Lloydminster area in western Saskatchewan. They correlate the core to the well logs, and then I give the students a set of 10 or 12 well logs away from the one well that has core, and to build a subsurface 3D reservoir model. And when I do this, and a lot of the work that we do, the style of report that I require of the students in my class is a professional style report. So I don't expect a long academic discourse. I want a short 5-page report, plus figures, that basically identifies the reservoir elements. It's a facies analysis. Creates the reservoir elements. Then you use the architecture from the well logs and the network of wells that you've got to build a 3-dimensional reservoir model. So in addition to the science that we're teaching, we're also training you in the aspects that make up a professional geologist or professional geophysicist. So how to write good professional reports, how to give good professional presentations. So we give you opportunities to do that during the coursework, and then at the end of the coursework, then we allow you to apply those new skills, both scientific skills and professional skills, to this exploration data set. So the professional skills include report writing. They include making professional presentations. In my winter term class, the basin analysis class, for example, you have 5 minutes or 8 minutes to do a presentation of a petroleum system from some oil-rich or gas-rich basin somewhere in the world. And it's the sort of presentation you would expect to make to a manager. You get chosen as, you're the exploration geologist who's charged with doing an appraisal on a basin your company's not in. Part of what you do is understand the petroleum system, and you've got 8 minutes to present it to your manager. That's the sort of thing that we do. We also try to create opportunities for you to engage with oil company people. And so there are a number of occasions where you'll do presentations as part of your course, and we'll invite company people to come up and listen to the presentations, and in fact they typically get engaged in grading your presentations. When we do field trips, we'll invite some oil company people to join us on the field trip, and typically they will do this. We've now graduated from the program, probably 150 or so graduates from the program, many of whom are in Calgary. And so sometimes what we'll do is have those alumni from the program come back and they'll participate in some of the presentations you do, or join us on field trips. We've also, don't do it all the time, but in the past we've had an alumni reunion, an IPG alumni reunion in Calgary, and if we do that, then we'll bring the busload of students from the current IPG program to join in, and there's some networking that goes on. So that's the idea behind the program. Many of our students have gone on to careers in the oil and gas industry, and now some of them, the ones that graduated 7 or 8 years ago, actually now have a fair amount of experience and have started to move up the ranks. Some of the companies that have hired a number of our graduates, if you know the Calgary industry at all, would include CNRL. Probably has eight or nine of our graduates on their staff. Husky has hired a lot. Repsol's hired a couple. Synovus, Shell, Imperial have hired graduates out of the program. Suncor has picked up a couple, I think. So it's a pretty good representation. There are other graduates of the program who are either working for consulting companies in Calgary. There's a company called GLJ, which is fairly active in Calgary, and they've hired something like 4 or 5 of our graduates. Service companies, so Schlumberger has picked up the odd graduate. A few others, seismic data vendors or seismic companies like TGS has hired some of our employees or some of our graduates. And one of our graduates has gone off to start his own company that does well site work. If you're not familiar with the business, there's always a geologist when a well is being drilled. There's always a geologist at the well site, keeping track of the samples that come up out of the hole, logging those, keeping track of the formations that the well is drilling through. Billy Chapasal did his own well site work for a while after he finished the program, and then started getting enough business that he started hiring other people, and now he's got his own business going. So, I would say up until probably 2 classes ago, we were very successful in getting our graduates hired. And most of them went into the oil and gas industry. A few of them went elsewhere. A few of them went into environmental geology firms. Some of them went into the mining industry. But the bulk of our graduates went into oil and gas, and many of those, certainly the Canadian ones, stayed in Calgary, and a lot of the international ones stayed in Calgary too. Obviously, everybody knows that the job market, the industry went through a big slump with the fall in oil and gas prices. That's now, 3 or 4 years old. For the first couple of years, we didn't really see that in our hiring. Most of even the group that graduated 2 years ago last August, most of them got jobs in the oil and gas industry, and most of them, as far as my records show, are still employed in the oil and gas industry. The group that graduated the year after that, tough times, although probably a third to half of them have jobs. The group that graduated last August, I know of, I think 3 or 4 that got jobs, and the others are still looking for jobs. So clearly it's been a tough go for the students who've come out in the last couple of years. So given all of that, what's the advantage, at least from my perspective, what's the advantage of going through a program like this? First of all, if you're out looking for a job, it's obviously competitive. There are a lot of people out there looking for jobs. And so one of the criteria that employers will look at is what are your credentials? Having a master's degree is a higher credential than having a bachelor's degree. So it's not a guarantee, obviously, that you're going to get a job. That's clear. But you have an advantage over recent hires that don't have a bachelor's degree. And I think by now we have a track record, the IPG program has a track record of training its graduates well. So, you've graduated from the program, doesn't guarantee you're going to get a job, but people in Calgary do know the program, and they do appreciate the value of a degree from the IPG program. The Calgary industry is now shifting in a way that, say, the US industry shifted 20 years ago in terms of the entry degree to be a successful geologist. If you go talk to people, and people working in the Calgary industry who are 45, 50 years old, a lot of them entered the business with bachelor's degrees. Same age, same demographic interval in the US, almost all of them have master's degrees. In the US, the entry degree to get into the business back in the 80s and 90s in the US was a master's degree, whereas it was a bachelor's degree in Canada. Canadian industry is now making that change, and pretty clearly it's going to be much harder to get into the business now with a bachelor's degree than it will be. It'll be harder with a bachelor's than it is with a master's, and it's hard enough with a master's degree. But all of that said, the skill set that you're learning to use geology, to integrate geology and geophysics, to use field relationships, to use science to predict what you're going to see in rocks that you're prospecting with a drill bit, works in a number of settings, even if you don't enter the oil and gas industry. There are mining companies that value the sorts of skills that we're teaching. There's a whole set of ore deposits. There's a whole class of ore deposits that occur in sedimentary rocks. And if you understand how to look at sedimentary rocks for prospecting for oil and gas, you've got a good foundation for looking for ore deposits that are also hosted in sedimentary rocks. Many of the same indicators that we use are the same for whether you're looking at ore deposits or whether you're looking for oil and gas. Understanding porosity and permeability patterns, understanding how fluids flow in the subsurface, understanding geomechanical properties. It's as important in prospecting for metals in sediment-hosted ore deposits as it is for looking for oil and gas. Environmental concerns. You're looking at sediment, you're still looking at sediments. You're still trying to understand how fluids flow through sediments. So many of the skills that you learn in the IPG program also work for environmental purposes and for geological engineering. It's also a valuable skill set. So, being a geologist is not a it's not a career path where you're necessarily going to get locked, or you shouldn't expect to be locked into a particular industry. I started out my career as an ore deposits geologist. I got a PhD looking at copper skarns in western Nevada. And then 3 years into my career as a professional ore deposits geologist, the company I was working for, Conoco, folded its minerals program, said, you know, learn oil and gas geology or go somewhere else. And at that point, copper was 60 cents a pound, and the only job I could have gotten was in Papua New Guinea. And my fiance said, you're going by yourself, Buster, if you take that job. And so I learned oil and gas geology, and it was not a hard transition because of the fundamental skills that I learned to do ore deposits geology turned out to transfer very well to oil and gas. And so here I am, you know, 30 some years later, still doing oil and gas. So don't get locked into the idea that just because you're training for one particular career, that what you learn can't be applied in others, and doors may open that you don't particularly expect. Up until the group a year ago, in the cohort that we had in the program a year ago, the size of the class coming through the program was about 25 students a year, which for us as instructors was a good number. It certainly kept us busy, but it, you know, we knew everybody, and we were able to teach on an one-on-one basis quite a lot. Last year's cohort was 13. This year's cohort is 10. And I expect we're going to be somewhere in that range for at least a couple more years. I don't see enrollments going up significantly. We've typically had about half Canadian students or Canadian plus permanent residents, and half international students in the class, and that's been a great mix for us. So this year we've got 10 10 students in the program. It's 5 and 5, Canadian and international. The international students come from, let's see, Nigeria, China, Vietnam, Mexico, yeah, and I think there's one. Yes, Felipe is from Brazil. It's a great mix. Everybody. It's much better having that mix of international than it is having all Canadian students. Everybody learns from each other, and honestly, in the end, the network of professional contacts that you build just from being in the program is going to benefit you in the long run. And it also, you know, don't think of yourself necessarily as being locked into a career in Canada. At some point, you'll probably have career opportunities that take you internationally, and you should jump at those opportunities. And having gone through a program with students from other countries is all to the good. Just a quick word about the application process. It's a graduate application through the University of Alberta. The application process is all highlighted online. If you go to the EAS, the Earth and Atmospheric Sciences website, there's a button for graduate programs, and all, you know, the details are there. But you want to apply as a Canadian. You can apply as late as the middle of April. And that's true for any international student except from China and Nigeria, in which case the deadline's a month earlier, because it takes a longer time from those two countries to get your study permit than it does from other countries. And so we need to process those applications earlier. But, you know, we start looking at applications, seriously at applications by the middle of February. So if you think this is something you want to do, and you get your application in earlier, we'll try and look at it sooner. And if nothing else, that may give you a little certainty in terms of what you might be doing next year. What else can I say? Some of you will be thinking about doing a research master's versus a course-based master's, right? And you know, if you've come through the program here and you've talked to some of the professors that you've met, you know, they'll say, go do a thesis somewhere. And there are benefits to doing a thesis that you won't get with the IPG program. On the other hand, there are benefits to the IPG program that you won't get from doing a thesis. And it's really, in the end, it's a matter of what appeals to you individually. A thesis master's is very much a specialization. You're going to, you know, you might work with John Waldron, my colleague, for example, and he's a structural geologist, and you're going to do a structural geology thesis. And in the end, you're going to have a very deep knowledge of structural geology as a result of that experience. Or you want to do, you know, carbonate sedimentology, so you do a thesis with Brian Jones, or clastic sedimentology, so you do a thesis with Dr. Zonneveld or Dr. Gingras at a master's level. And you know a lot about that. The IPG program gives you a broader training, okay? If you do IPG, you're going to learn a lot about sedimentology, but you're also going to learn about engineering, and you're going to learn about seismic data, and you're going to learn about you know, thinking about petroleum systems and basin modeling and that kind of stuff. So it's going to give you a synoptic view of petroleum science that you won't get doing a thesis. What do you want? What do you want to be, a generalist? Do you want to be a specialist? That's the kind of, you know, at some point, you know, think about that and decide which appeals to you. There are some more practical effects of doing thesis-based masters versus an IPG. IPG finishes faster. IPG is a one-year program. You work like a dog for, you know, 12 months, and then you're done. A thesis master's is 2 to 3 years. IPG costs money. A thesis master's, you are typically have a research assistantship or a TA, and so you're not paying out for the time that you're a student. On the other hand, you get to the end point sooner, and you can start earning money sooner. So, you know, there are those sort of practical considerations as well. But really, I think those, at least to my mind, those are secondary, and the real difference, the significant difference is, you know, the broad training that you get through IPG, or the specialized training that you get through doing a thesis. I will say, some companies will tell you that they prefer a thesis, somebody who's done a thesis, a master's thesis. That's more typical of the big companies, but not exclusive to them. Or they don't hold that view exclusively. Their idea, and this is certainly true in the US, I think it's less true in Canada, but a company like Exxon in the US will say, we're going to hire thesis-based masters because we know that if you've done a thesis, you can take a major project through to completion. Okay, that's their philosophy. If you don't have that experience of doing a thesis scale project in IPG, you're doing capstone project, yes, but a 3-month project is not the same as a thesis where you've spent a year and a half on a project, and in the end you've written up a substantial report. We understand that. I think it's less I think the Canadian companies are a little bit less rigid on that point. But we also make the IPG program deliberately challenging. No, it's hard. It's hard because we want the graduates who've come out of IPG. We want the potential employers to say, "You finished IPG. We know how challenging IPG is. We know about the high standards that the faculty set. If you've done well in the IPG program, we know we know that you're good." That's the philosophy that we have. So it's a tough program, and we make it so deliberately because in the end we think that the high standards that we set make graduates of the program. We make the value of graduates of the program apparent to potential employers. So I guess that's kind of my pitch. Did I leave anything out? Price. So for Canadian students, it is an inexpensive program. If you're Canadian or a permanent resident, the current tuition has been set at approximately $9,500 for the year. And if you go anywhere else to any other program, you will undoubtedly find it. You won't find anything cheaper, and you probably find it a lot more expensive. The tuition for international students is significantly higher. It is $38,000 or $39,000. You will find, if you look at the other high-quality programs that are out there, that IPG is set really at the low end of the tuition scale that most of the good programs charge. So there are equivalent programs in the UK, Netherlands, there's one in France. There are good programs in Australia. There's one in University of Houston in the US. And for the international tuition at those programs ranges from in Canadian dollars from about $45,000 to $60,000. I assume that I assume that nobody has lowered their tuition rate. It's conceivable that they've done so, but those were the tuitions that I looked at about a year ago. So, for international students, it's a lot of money, absolutely. It is still cheaper than what you're going to find if you go to any other one of the major programs as well. Okay? So, ask away. No questions?
Do you mind if I send out if anyone needs your contact information?
Absolutely, yeah. You can send an email around. I'm just down the hall in office 204. In the back corner of that lab. And I'm around a lot. So, you know, I'm on the faculty roster, and my door is generally open. So, absolutely. Yeah, we have a website, we have brochures and so on. Okay. Really no questions. Okay. Well, I'm not going to keep you if you don't have anything, but I'm happy to sit around and talk for a little while informally after you're free to go.